Karnataka's single window system handles business registrations, but 40 plus legacy department systems are still live, each with its own schema, its own identifiers, and no way to stay in sync. UBID Interop Mesh solves this, an audit first interoperability layer that propagates service requests in both directions without modifying either side. Here is the split brain reality. A business updates its address on the single window system. Shop establishment holds a completely different version. Neither side knows the other exists. Until now, there was no bridge between these worlds. Let us walk through a real trace. Aravind Textile Mills updates its registered address on the single window system at 9:14 a.m. The mesh picks up the event, translates it into each target department schema, and propagates to three systems simultaneously. Shop establishment confirms in 9 seconds. KSPCB confirms in 6. The factory's connector hits a 503 error and automatically retries. Every step is logged with an immutable event ID. 40 plus departments means 40 plus different schemas. The translation mapping workbench lets operators define how each field maps to the canonical model. Canonical on the left, department on the right. Here we are onboarding the fire department. Their system stores premise area in square feet. A single expression converts it to square meters and runs a unit test directly in the workbench. License status codes ARS are mapped through a lookup table. Every mapping is versioned and auditable. What happens when both sides update the same record at the same time? At 11:23 a.m. SWS sends an address change. 24 seconds later, the factory CDC connector picks up its own address change for the same UBID. The conflict engine detects the overlap within a 60-second window. Because address is a critical field, the policy is human review. The operator sees both versions side by side, normalizes the addresses, confirms they are semantically identical, and accepts the SWS version. Every decision is recorded in the immutable audit trail. The reconciliation dashboard shows the full picture: 12,000 propagations in the last hour at 98.6% success. 5 connectors across departments. BISCOM is down 47 items in the dead letter queue, all failing with force order 1 after an API key rotation at 8 am. The operator can validate the new key and retry all 47 queued items with a single click. Under the hood, 4 layers. The ingress layer consumes webhooks, CDC feeds, and file watches from every department. The reasoning layer runs the conflict engine, translation engine, and idempotency checker. Kafka provides 6 log compacted topics as the event backbone. Redis holds idempotency keys and conflict window state. The audit layer powers the immutable timeline. The export layer generates reconciliation reports, PDF audit trails, and Prometheus metrics for SRE dashboards. Round 2 replaces the in-memory simulation with a real Kafka cluster and 3 live connectors. The normalizer, conflict engine, and translation engine become Kafka Streams microservices. A schema registry built on PostgreSQL and Apicurio powers the mapping workbench directly. With idempotency in Redis, a dead letter pipeline, and end-to-end traceability across every connector. UBID Interop Mesh, one join key, two-way sync, zero changes to source systems.